Okay, so my name is Michael Cain. That's clearly not the right one. That's me. I'm senior Ruby developer at a company called Thrive TRM. We're hiring. If anybody's interested, please hit me up afterwards. We'd love to talk to you. What we're going to cover today are some of the new features in Ruby 3 and some of the additional syntax changes. So as some of you may be aware, there has been a concerted effort over like the last 18 to 24 months to make Ruby 3 times faster than Ruby 2. If you check out the release notes from Ruby 3, you'll see we pretty much are there. The problem is for all of you Rails developers, we really don't get to take advantage of that until we work out some of the discrepancies between active record and whatnot. So some of the performance issues the performance improvements may not directly apply to you. If you are a raw Ruby developer, then certainly they'll benefit you as well. So we'll just stick to some of the new features that have rolled out. So the first one is RBS. So it's short for Ruby Signature. So what RBS is, in short, is a way of providing documentation for statically typing Ruby. As many of you know, Ruby is a dynamically typed language, which offers us a lot of flexibility. There have been movements in the code community as of late to kind of try to migrate back to more statically typed languages. So we have this library, should you choose to make Ruby more statically typed, to do that for you. Goal of RBS, according to the release notes, I trust you can read. And actually, as you'll see here, this is essentially what the syntax for RBS looks like. So if you're familiar at all with Java, it has kind of a Java-y feel. So I apologize if there's any PTSD going on. As you can see up here with like the add readers, you'll tell RBS what type is specific to the attribute. Arrays and hashes are called containers. So they're special in as much as not only are you going to have the container static type, but it will also have whatever is contained within the array will be typed as well. In this case, it would be a message object. This little pipe here is for unions. So essentially what this says is users can be an array of either a user object or a bot object, which will allow us to take advantage of a lot of conventions that we have with like duck typing, while still getting the benefit of tightly taking advantage of the statically typed nature of RBS. If you've never seen this kind of syntax before, essentially this is the method name, what it takes for params, and what it returns. So as many of you know, Ruby typically will return the last thing that it evaluated. With RBS, in this particular case, you can have something that returns absolutely nothing at all. Also with the post here, you can see that we can also overload methods. So you can have differentiations, whether in this particular instance, the message is going to be a string or the message can be a file, while you can statically type the remainder of the class in this case. So when it comes to how you organize RBS files, there's two clear distinctions. There is the environment and the definition. So the environment is essentially the thing that contains all of the various definitions, from what ships with Ruby itself and any custom RBS files that you might have. And then the definition, which is essentially what I showed you on the previous slide, is how your particular class is defined, all of the attending class and instance methods that go with it. So there's basically three steps. So if you wanted to load a new environment, I put the steps here. The two key takeaways is you can have a path that you can add to the environment or to the loader, essentially, where you could have all of your own custom RBS files. This is probably the most common use case for it. If you had a particular library you wanted to load, again, we'll provide you a particular manner in which to load that library into your environment. So once you have the environment, resolve type names will essentially gather up all of those files and make them available to you in your environment. So when you have your environment loaded, this is how you get access to all of the declarations. So in this case, we want to access the string class. So you create this namespace type name class. Just basically tell it this is the class I want and the namespace in which it exists, which was derived essentially from your environment. The builder is going to be important on the next slide because it's the builder that's going to provide us the manner in which to build declarations into definitions. So when you want to see what instance methods are available, what other overloaded methods might be available, anything you've customized yourself, the builder will do all of that for you over here. So when we want to see what's available in the instance level of a class, you use the builder to build the instance, and then as the slide will show, you basically tell it, show me all the methods, or use the G sub key on the methods collection, and then give me all the method types. So this is essentially what comes out of the box with Rails. You can go look at the documentation on the Ruby API page, and it looks exactly like this. So how would any of this be useful? Two things that kind of popped out to me. One, it creates like a source of truth. So as we previously discussed, statically typing your code can be advantageous. It can help reduce bugs. It can make things a little more clear if you have third-party libraries you're integrating with. So providing all of that as shared documentation to your engineering team can be beneficial. Again, like proactively aligning your types. I know in my personal experience, it makes it a little more clear as what is receiving what. If there's any kind of typecasting you have to do, which when you get into statically typed languages, you have to worry about, having all of that documentation available is beneficial. What's also cool is if you've ever monkey patched root, so if you're not familiar with what monkey patching is, it's essentially overloading or overwriting native Ruby methods. Something that typically is pretty verboten. Using in specific environments, you can basically create your own custom environment and create your own implementation of a string class or a hash or whatever you need that has whatever. If you had a method that you wanted to overload specifically, you could do that in the context of an RBS environment and have that kind of off to the side and have that and just kind of load that wherever you require it. So then you're not going to get into conditions where you're clobbering methods that other parts of your application might want to be able to use. So typeprof. Typeprof is a tool you can use to turn your regular Ruby classes into RBS. So there's actually this little playground right here. So we're going to see how brave I can be. Get out of here, and I'll just take you to the, this is not going to work. Okay, so we'll do it at the end. So there's a cool playground. If you go here, and I'll show you when it's done, like you can essentially put your classes into this playground and it will generate what the RBS would be on the side, which is actually pretty cool. So put a pin in that. Raptors. So one of the things we have wanted to try to emulate is parallelism. Ruby has a rather unfair reputation of being slow and not supporting parallelism very well, unlike a lot of the more modern languages like Golang or Rust or Elixir. So we wanted to come up with a solution for Ruby, which is what the Raptor model is. So if you're not familiar with how parallelism has been implemented in other languages, these use what's called an actor model. An actor is essentially like the primary type within a parallel language. It's the thing that acts upon the system, as you can imagine, and is thread safe. So you can't share data among actors, unlike threads. So how do Raptors work? So when you create a Raptor, typically what Raptors will be instantiated, and you'll pass them the block. So the block that you pass a Raptor is the thing that's going to be executed in its Raptor context. Now, you don't have to pass it a block right away, but from the documentation that I've seen, that's typically how you would instantiate it. Should you choose to name your Raptor, you may do so. So Raptors can send or receive messages. So when you send a ractor a message, or there's two parts to a ractor, you're going to have the incoming port and then the attending queue. So the queue is infinitely long, but essentially anything that happens in the context of a ractor is executed serially, while things that happen between ractors happen in parallel. So for example, you can have a ractor that's going to wait to receive. So this is going to pop something off of the incoming queue. So if you instantiate a ractor and then pass it a proc or pass it a param, it will wait to receive that and then execute whatever you want to do in the context of said ractor. Take is how you pull off of the response queue. So ractors basically have an incoming queue and an outgoing port. So if you want to take whatever was processed in the context of a ractor, you can call take manually. So there's a couple ways in which we can make ractors work for us. So you can send the ractor your data into the incoming queue. Once the ractor has processed the block or whatever you've passed it, it can either be called off with the receive, or you can call take on the ractor itself. So there's two particular contexts in which you might want to do this. It kind of depends on the context, really. So say that you want your first ractor, R1, is like the active, is like the parent to the child. So when ractor 1 is done, it's going to call send on ractor 2, and ractor 2 will receive it on its incoming port. Now, say you wanted ractor 2 to be active and ractor 1 to be passive, you can simply call yield in the context of ractor 1, and the ractor 2 will call take on the first ractor. So again, it kind of comes into how you want to manage the workflow. Okay. You can also chain them together. So in this particular case, ractor has a method called select, which is going to wait for, in this case, R1 and R2 to complete, and then pass, then it will manually take what comes off of those individual ractors and process them in the subsequent ractor accordingly. So if there are, you have like built-in serialism when you need it. If say R1 and R2 were blocking for this particular ractor, but could be processed in parallel on their own, then you would use a model like this. So when would you practically apply ractors? Two examples I thought of, again, we have to consider this outside of the context of Rails. So you had a microservice that aggregated various data from several APIs. Like we used to do this at Comcast all the time. Like I have to go fetch data from several places and kind of collate it into one response and fire back that response. A ractor would be a great way to do that because I can make several API calls in parallel. I can wait for their request to complete, take the response into a subsequent ractor like the model I just showed you, marshal it all together real nice, and pass it back to the client or whoever asked for it. Fiber scheduler. So unlike a ractor, fibers are like a more lightweight manner of threading. Fibers have been around a little longer, along with the thread class, but the scheduler itself is rather new. Now, unlike the ractor, there's only specific kinds of operations that fibers will work with. So I have them on screen. Essentially, it's basically fundamental IO or kernel-centric methods. So how would you use a fiber? What the key here is this method right here. So the way that the Ruby VM, if you're using C Ruby, this is also works with JRuby and Truffle Ruby if you use those as well. The C Ruby interpreter is going to look for whether or not this is set with a scheduler. So what the scheduler would do is going to interrupt these various, say for example, we were looking at these IO operations, like wait readable, get, put, what have you. If you have the scheduler set in this context, the interpreter is going to know that and is going to hand off those operations to the, however the underlying machine handles scheduling. So it's key if you want to play around with fibers, that you set this before you start doing any work. So for example, say we have a collection of PDFs, right? Every book on parallel code you ever wanted to write, you've got in a file, and you want to read them and send the response somewhere. What you can do is essentially take the IO operation that you would normally do and just simply wrap that in the fiber schedule method. So like I said, what that's going to do is when those operations occur, the VM is going to know that you have the scheduler available, and we'll just hand all of this off to the underlying machine, and the schedule method within the fiber class is going to know how to like wait for, do all the various thread management under the hood for you. So it's a very convenient way to deal with parallel threading. If you wanted to do something outside of just the machine, there's a gem called async. There's a really good presentation on the web that I'll hook you up with afterwards. Essentially what the async gem will do was leverage all of that fiber stuff for example, in this case, HTTP requests. So in this particular example, you wrap the whole operation in an async, and then for each one of the particular topics, as is denoted here, you can pass it off to async again. And what async is essentially handling for you is all of that fiber thread management under the hood. So now we can, just like we were using with Raptors, have a similar async approach to hitting these various endpoints. So async has a few other libraries. A lot of them are like, they're pretty brand new. Async HTTP is basically what you just saw. There's a WebSocket library as well. Falcon is a rack compatible async HTTP server. So Falcon, if you check out the talk that I'll send you afterwards, they basically did a side-by-side comparison of how Falcon compares to Puma, and being able to manage a multiplexed requests through HTTP is like super performant. Again, the problem we have with the Rails community is the active record connections are one connection per thread. So when you get into multiplexing requests, you run into requests happening on similar threads and things can break. So this DB gem that they've created was essentially supplant whether you're using the PG gem for Postgres or MySQL or Redis. They will allow you to leverage the async parallel access to your database underneath the hood. Again, it's relatively new, so I don't know how whole hog I would go on it, but I definitely encourage you to have a look, and it's super performant. So when would you want to apply Fiber Scheduler? So I'm a huge fan of asyncing all the things when you can. Whether if you're making, I know like my current job, we have a lot of collated API responses where a request for, say, a candidacy is going to require fetching data from 2 or 3 or 4 different tables and kind of coalescing them all together. Being able to do those calls parallel instead of in the serial call would be super helpful. Kind of like what we were looking at for Raptors. If you have multiple HTTP or API requests that you have to make, again, if you're collating third-party libraries, to be able to do all that in parallel is super helpful. If you wanted to just use the Fiber Schedule out of the box, if you are processing large, I don't know, scientific, files of any kind, or like machine learning kind of stuff, I'm sure the Fiber Scheduler could be super handy when you're dealing with that kind of large I/O. So that's all of the brand new features of Ruby 3. There are some new cool syntax changes, aka cool new stuff. If anybody's ever played with Elixir, one of the strengths of Elixir is pattern matching. So we have improved pattern matching now. So as you can see, you can have a hash, match out the key that you're looking for, and it will suddenly return the value. I thought was super cool was this new way of managing cases. I don't know about you guys, but I have definitely gone down the rabbit hole of like huge if else if blocks or painful case and when blocks. So having something like this, where I have very specific Booleans, for lack of a better word, you can pattern match everything in the middle and out, which I thought was super cool. I haven't had much of a chance to play with this, but it's definitely on my radar. If you hate having to put interesting semicolons, endless methods are available now. So no more painful semicolons for you. Hash actually pulled the except out of the enumerable and stuck it in hash itself. So now you don't have to enumerate over hashes to get except. It comes right out of the box. So thank you very much. I know it went a little bit fast. If you guys have any questions, I'm happy to answer them now.
I have a comment, not really a question.
Okay.
I did some experimentation with Raptors over the weekend, and I was extremely underwhelmed. I learned that I have a desktop machine with 24 CPUs, and I learned that when I used the 24 CPUs, it was only, well, it was about 2/3 of the time it took compared with using one CPU. So only a saving of about 1/3. And in addition, the CPUs collectively were doing about 10 times as much work. So it's a great idea, and I'm sure it'll get efficient. But right now, it's you know, I would not recommend using it for real world production use.
Fair enough.
Yeah. Also, I'd like to clarify something. I think when we specify that a method is void, what I think we're really saying is that it returns nil, which is the closest thing that Ruby has to being a void method.
Right.
But yeah. Okay.
Yeah, I had a question about, I don't know if I read this correctly somewhere, but isn't there a gem or some sort of library out there that connects yard documentation to RBS? So you can basically use this syntax for defining like what the method does and what the parameters are, and then it kind of translated to RBS for you. Have you read about that?
Can't say I'm familiar, but it sounds like something that would be totally applicable. Actually, that reminds me. I wanted to show off if this is.
I have heard that they can read, you can read yard documents, documentation into definitions.
Yeah.
Oh, cool.
So I did want to show you guys this. Oh, that's the one right there. So this.
If you have any other questions for Michael, feel free to raise your hand using the Zoom feature or type it in the Slack. I think we'll have time to go over them.
Sure. So here's that playground that I was telling you about. So on the left here, we have our Ruby class. And on the right, we have basically the RBS docs that get spit out. So you can see without instantiating your class, RBS doesn't really know what's going on. It has to try to infer from your code what kind of types you're using. But if I did something like this, if this will play nice, I'll use the wrong thing. User live code is always risky. New. So we need a name. 2 eyes, that's cool. An email. Feel free to spam me. Age is 21. Not true, but cool. Now, if I analyze this, this will be able to interpret from what I'm passing as arguments all the types that I'm using. So that was pretty cool. Say you want to use keywords for this. This will likely break. Yes, it will. So then we can pass them down here. Analyze that. And now in the initialize method, these keys are get specific. So that's cool. Let me show you what a union is going to look like. So say I had a method like can drink. We say if age is greater than 20. True, else. No booze for you. When that analyzes that method, it's going to show either I can receive a string in return or true. So that's what those unions look like. So I thought that was pretty cool. This I'll throw this guy in Slack if you guys want to play with this thing. This is pretty neat. You can copy paste whatever you want in there. Boom.
Very good. Thank you.
Sure.
I think Philip has a question about RBS. Philip, you want to go ahead and ask your question?
Sure. I was just trying to see the use case for this. I mean, would I be publishing perhaps a header file for people to consume and know how to interact with my gem if I'm making one? Or why would I generate a signature file?
That's a good question. I think for my money's worth, it'd be some kind of documentation that I want to have available to my team. We have a pretty segregated back end and front end teams where I work, so I think I would imagine that it would be helpful to have this kind of documentation in a repository. So if a front end engineer was hitting one of my APIs and wanted to know exactly what they would get in return, this kind of documentation would be able to provide it to them. So if there was ever, it's kind of like a de facto data contract, as far as I can tell. I can't say I've really worked with a lot of statically typed languages myself in the wild. So I kind of share your perspective. I'm like not really sure what the value is here, but if I had to guess, having some sort of documentation available to share, whether it's a consumer of a gem or whatnot, giving them some kind of indication ahead of time of what your return values are going to be or what are permitted params might be useful.
I think I can add to that. Sorbet, which is a similar tool, I believe will allow IDEs, specifically VS Code, to check your code as you're writing it to make sure that it's valid according to the contract. And also, I believe there was something in there about if an error occurs at runtime, it handles it more gracefully or expressively than what would usually happen in such a case.
Mm-hmm.
Are there any performance implications? Like if I do have a signature file and I'm using it in my application, is it going to affect performance at all in production?
Not that I read. So with the fact that it's a relatively new and experimental feature, your mileage may vary, but I did not, from my research, get any indication there would be any performance impact from using it.
Regarding that, Sorbet is like a big competitor to RBS, kind of, although I think they're working together. And Sorbet was written in C++ for the very express purpose of it being super, super fast. And they claim, and I believe them, that it adds very little overhead at runtime. They talk about like just ridiculous numbers of lines of code being able to be processed in a split second, like millions or something.
Nice.
Yeah.
All right. Any other questions for Michael?
I have a question. When we declare an array to be a union, does that I believe that means that each element can be any of the types in that union, correct? And not that the entire array has to be one of the types of the union.
As in, you have an array with a union of two separate types? Is that the question? Yes. Yeah. From then anything within the array, as long as it fulfills one of the, it is one of the types within the union, yeah, that should be fine.
Is there a way to specify that that all elements in the array have to be one or the other types in the union. And I'm not sure that this really has any use case. I don't know, but I'm just kind of curious.
Like a bitwise or I couldn't tell you. I haven't had it. I didn't experiment with it enough to know, but that's a great question.
Thanks.
I had a question. Could you expand a little bit about why, like I understand that Ruby 3 is 3 times more performant than Ruby 2. Could you expand a little and explain why Rails cannot like benefit from some of that performance improvements?
Sure. So according to the documentation, one of the challenges that we have with Rails is there's so many methods in play that it suffers from what they're calling an iCache miss, which is exacerbated by the new just-in-time compiler. So the Ruby 3 JIT was significantly reduced in size. So that's where a lot of their performance benefits come from. The challenge is, according to the documentation, there's just so much happening in Rails relative to the number of methods that it's managing at a time. It kind of just overruns whatever benefits the just-in-time compiler is getting for you. They're telling us that Ruby 3.1 is going to be better, but you know, from what I've gleaned, there's so much happening with like the Rails magic side, right? There's just a lot of stuff happening under the hood that it just the caching that the JIT provides is really just kind of blown out the door. So hopefully in the future we'll be able to benefit from it in relative short order.
I think, in other words, to state that differently, there's just so many of the methods that are being called in a Rails application are created dynamically at runtime and are not able to be determined before the program runs. So RBS just isn't capable of knowing what they are.
Yep.
Got it. Thanks. Thanks for adding more.
Sure. All
right. Well, if you have any other questions, now is a good time to ask them. If not, you're going to have to do it asynchronously. All right, cool. So yeah, oh, and if you see the comments in the chat, Megan shared that project that is kind of like a connection between Yard comments and RBS, and I think maybe even Sorbet as well. So thanks for finding that, Meg. Cool. Well, thanks a lot, Michael, for. Okay.
Sure.
Cool. Well, yeah, if you have other questions, you can probably post them to the meetup event and maybe Michael can look into them later. I hope that, yeah, you can all stay safe, and I hope to see you again in the February meetup. Again, if you're interested in speaking, there will be a link in the meetup page. You can follow it and submit details for your talk. Could be a lightning talk, could be a full-fledged talk. We're pretty flexible there. And anyway, thanks a lot for being here.
Cheers.
Thank you very much.
Thank you.
All right, bye-bye.
Everyone, thanks.
Yeah.